about right here. So we just talked about the binomial stuff. We went through some examples. I don't think we did hot dogs. Did we do hot dogs? I can't remember. Oh, we did? Okay, so then we're going to move on from hot dogs. Okay, so we got this problem here and onwards. Every single time we do binomial, we need to have three numbers in specific. We need to have, We need to have n, which is my total. I need to have x, which is like my selected. And then I need to have p, which is my probability. Those are the three things that I need from each one of these. So total, selected, and probability. And so looking around here, it says blah, 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 blah. It says you randomly select 6 people to participate. Now, I know it says select right here, but these people are the total amount in our survey here. Like it says like select, but I'm wanting to say like they grab 6 people off the street and they're going to start asking them stuff. So that's actually going to be my total for this one. Now, each selected option is right here. Do you see how they have X's right here and all the different options? So they're asking about their driving habits. And they're going to ask specifically about, do you see it there? Cell phones, right here. It says let X represent the cell phones. Cell phones, right there. Cool? So 6 is going to be the total people that I'm asking right now, and they can say yes or no to my survey. They're asking about cell phone use. So you're going to say, are cell phones like annoying to you? And you're going to say yes or no. Yeah, binomial, true, false, yes, no. Cheese or no cheese. So my probability is 0.32. Again, the X is going to be something weird. They actually, here in this particular question, want you to have all these different X's at once. We're going to fill them all in. Hey guys, look, there was already an N and a P down here. Now I feel kind of silly. So now let's go ahead and fill in all these guys. Now in GeoGebra notes, there's nothing for me to write. That's for you. I'm just going to go back through the process again, and you're going to, jot down whatever things are best for you. Okay. Are we okay so far with the people and the probability? Yeah. No. Yeah. Okay. I know. It's like, Chad, what are we doing? I know. Well, we're doing math. So GeoGebra, and we're going to go to Classic, I think. Would this no? Is there a button for Classic? Have y'all ever found a button for Classic? No, you always have to type it. Isn't that weird? But like that's the only way I know how to get into this stuff. Okay, so we're going to go to probability. And again, if this didn't pop up, you got to click like the triple dots, triple bars, something like that. But we want to get the probability, okay? You all have devices, that's good. So yeah, probability. And this is the nice bell curve, but what we want is binomial. So it has the normal right here in the corner, and I'm going to change it to binomial instead. And again, in other sections, we'll just change it to something else, whatever we need at the time. So right now we're binomial, we do binomial. Another time we do Poisson, we're going to do Poisson. So binomial. And they say find n, find p. What was my n? Do you remember? Cool. P was perfect. So I just type them in right now. I think the graph is not really meaningful that much. What we really need are these numbers on the side, right? Those are the actual numbers that are important to us. And so last time they were saying, find the probability of exactly whatever, and it was just a number. So, I mean, those are your answers right here. These are the answers. And those are the answers for this one as well. So let me side by side it here. I don't really care about the bottom. I'm just looking right here. So they say, what's the probability of 0? So you're saying, hey, are cell phones like not cool? And they're going to say yes or no. And what's the probability of 0 of them saying that they're not cool? Right? So that would be my probability, 0.0989. What's the probability that only one of them would say, yeah, that's not cool? So 2792. What's the probability of 2? Out of these 6, we have 6 people we're asking. What's the probability of just 2 of them saying that they don't like cell phones would be these guys. Are y'all okay with what I'm doing? Like just one by one by one? It was kind of silly, but at least they're all there. Okay, awesome. Cool. Good. Good. Okay, awesome. Sweet. So now they're going to ask more specific questions about this. And like we already have the numbers. So here we go. It says find the probability of exactly 2. What would I put in this box? What do you think? Yeah, 0.3284. Exactly. It's right there. 2. That seems easy enough, right? Now it says greater than or equal to 5. What would I have to add up? Yeah, the 5 and the 6, right? This guy and this guy. Add them up. Exactly. Add those 2 up. And then we get our answer. Oh, now I have to actually add. 0, 1, 4, 8. I think so. Yeah, there we go. Sweet. That was it. Yeah? Is that okay? Good. Cool. Good over there? Good, 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 good. Okay. Nice. Okay. If you need something, you let me know. I'm going to keep cruising now. Keep scrolling. Here we go. Oh, I love this kind of stuff. So we need to interpret from the words all of our numbers. So it says 64% pause. Like, isn't that a number in a way? Right? 64% of pet owners say that they consider their pet to be their best friend. Oh, that's so nice. Well, I mean, I do have Spud. I mean, he's my best friend right now. People have been drawing things on the board about him recently. Okay, so you randomly select 10 pet owners. Okay, so that's going to be the total people I'm looking at. Hello. And you ask them, hey, is your pet your best friend? And they go, woof. So, I'm sorry, you walked into this. Find the probability that this and that, et cetera, et cetera. So, what is my N? 10. Yep. What's my P? What would I put in there? What is it? Yep, 0.64. Very good, very good. Putting those in right now. Awesome. And now they're going to ask the more specific questions. So it says exactly 9. They're saying like x equals 9, I guess. But that's fine. I don't really need that, I suppose. You can just go over here and look. There you go, right here, 9. And like there's my answers. They're all sitting there, you know. So 0, 6, 4, 9. Ta-da! So I ask 10 people, is your pet your best? Exactly 9 out of those 10 saying that it's the best friend and all that is 6%. Again, that's exactly 9, not 8, not 10. Okay, cool. It says at least 7. What does it mean to be at least 7? Like what numbers would that be? Say it again. 7 and above. Yeah, 7 and above. 7, 8, 9, or all 10 of them, right? Exactly. So yeah, 7 and above. I think there's a way to like select these. I had it at one point, maybe. Do I like double click maybe? Double click? Okay, well, you can go down here. If you want to make it a little bit faster, because you can add them individually, but if you just type down here and you say 7 to 10, 7 to 10, basically, and you can double check, am I highlighting all those things? Yes. So we're good to go. This is the addition, the sum of it. And you can even check it, right? That's about 30 something, 40. There you go. So that's about 40. We're good. So just a quicker version, I guess, of doing that. There we go. Awesome. I don't know what they're wanting to go with right here. This is actually a little bit frustrating to me. But they're saying the probability is represented by, and that's going to be the greater than or equal to 0 or 1 minus x is less than 7. I don't know. That's fine. I don't know what they're going with there. That's just them being silly. And then at most 3. What numbers would that be? 0, 1, 2, and even 3, right? 3 would be the most. So let's do that. So I can say all like 0 out of the 10 say they're best friend, all the way up to 3 say that it's the best friend, and we got that much. And you can kind of verify that these numbers make sense, right? I'm looking here on my bar graph, and it's kind of small. It's kind of small, so that makes sense. Sweet. Good so far? Okay, cool. Hopefully I'm not boring y'all. That's the main thing. I don't want to have it boring. I'm going to try to be happy. I'll just drink some coffee, and it went nuts. As in me, I did. So it was crazy. They were all laughing at me and stuff, and I just did not know what was going on. I'm going to try not to do that here, but here we go. Computer graphics card manufacturer testing improvement of this. If a sample of 100 graphics cards were used, the new process, hello. It says has to have a less than 10% chance of having 3 or more. 3 or more defective. Let me erase that. 3 or more defective. Then they'll switch to a new process. If the probability of defective card is this much, are they going to switch to a new process? Now, I got to say, this is one of the more confusing problems to me, and I just get lost every time about what is going on. It's almost too many numbers, you know. So I have a sample of 100 graphics cards, and they're wanting to just see, are we going to get this defective stuff, okay? Actually are P, I think. So I'm going to go with N is 100, and I'm going to go with P is the 0.009. Is that correct? Help me out there, guys. It's not 9%. It's 0.9%. Would I be shifting it that much? Right, because I have to go an extra one, right? Let's try that. Again, I'm a little bit clueless, honestly, if this is going to be great or not, but we're going to try. 009. Okay. They're wanting to know if I'm going to have 3 or more defective. Okay. Now you can see that I have some numbers here. 3 or more defective would be like all these guys here, right? Let me actually put those into here. I'm going to go like 3 to 100. Okay. 3 or more defective. That would include the 3. Am I correct in understanding that? They're saying 3 or more defective. That would be like 4, 5, 6, 7, 10 or whatever. Well, like there's a 0 probability of 10 happening, right? It's just not going to happen. So at this point, it's like you're adding up a bunch of zeros and it doesn't really matter. What we're really wanting is just that stuff up there. And they already did it for us. So we're adding those together. And what I got, so I'm going to write this thing down, 3, 4, 5, 6, all the way out. We got a probability of 0.062. Let me rewrite that a little bit clearer. That's what I got. And so I want to do like a percentage. What percentage would this be? Yeah, 6.2%, right? 6.2%. That's not like an answer that I can put in, but I'm understanding that blah, blah, blah defective, I've got 6%. So it seems okay. It seems like everything's good. So I'm just going to reread it. If the sample of the new process has less than 10%, then they're going to switch to this new process. Okay, so that's what they're kind of going with. So everything's cool. We like it. It's better than what we've had. Do we switch? I would say yes. So those are good because the probability of having 3 or more is greater than? No. because the defective of less than 10%. There we go. Are y'all like this is a really, oh, is it a crazy problem? Is it that crazy? Okay. You're just making it, I'm like looking at it like, oh no. Are y'all okay with what I was doing? When, not if, when you see this problem on the homework, now you know what to do. Look for the big number for your n, and then look for this guy is your actual percentage. Notice again, it was very tempting to use 10% in there because that, oh, probability, right? That's what we're testing against later. Okay, cool. All right. That was really one of the harder ones. Oh, okay, we can do this now. Good. Let's roll on. Here we go. Let's keep going. So, population parameters. Now, we got all these cool things. We got the mean, variance, standard deviation. These are actually the formulas that we will have to use. I know that GeoGebra gives us a whole lot of stuff, but like I gotta say, these are very simple. All we're gonna do is multiply some numbers and just that's it. Very straightforward. So let's do this. It says find all these, given I have this n and this p. So here, let's find the mean. What am I going to do with the n and the p to find my mean? Yeah, exactly. I'm going to multiply them. This calls for a calculator. I'm going to use Desmos. Just a little bit partial to Desmos. So 50 times 0.735. Okay. Variance. Now you see that we need a Q. And just as a side formula, that's, oops, let me redo it. We got Q is equal to 1 minus P. And so for our case here, Q would be 1 minus the 0.7, which makes, 0.3, 70, 30, right? So variance, 50 times the 0.7 times the 0.3, multiply them all together. Oops, I blame the keyboard. Of course you would, Chad. When I'm like terrible handwriting, terrible everything else. Totally, it's the tablet's fault for drawing weird. No, Chad, it's not. Standard deviation. They say basically what I had, my variance, and I'm just going to take the square root of it. So whatever I had, square root, and there we go. So square root of the 10.5. And here we go. 3.24. And there we go. Let's pause. Is this okay so far? Yeah? Yeah? Yeah. Okay. Are you okay with taking your n and your p and multiplying for that guy? Okay, cool. To find the q, it's always opposite of the p. So they say like 70, so I got to go 30. 50, 50, 60, 40, 20, 80, 10, 90, 1, 99. Is that okay? And then I just say, calculator. Okay, cool. Good. Oh, are you, say that one more time? Sorry. Yes, just leave it alone. Very good. What does this mean, right? What does this mean? Oh, Chad's being silly again. It means that's the average. So I'm saying I have 50 people I'm going to survey, and there's a 70% chance they're going to say yes. So I'm going to ask 50 people, do you want cheese on your hamburger? And there's a 70% chance that they're going to say yes. So on average, how many slices of cheese do I need to get for this group of 50? 35. 35 on average. This variance means nothing to me because it just means nothing. We don't use it for anything. But the standard deviation's good. I'm saying now 3 slices of cheese on either side. And so again, this is maybe going way too much into it, and you're like, Chad, you're just blabbering. I know. I haven't even had coffee yet. But right here, I'm going to add 3 to make a 38. Add another 3 to make a 41. Minus 3 to make a 32. and over here I would get a 29. And as you know, this is the usual zone. This is usual numbers. So let's just say that I'm a cheapo and I don't want a whole lot of slices of cheese. Ain't people getting cheese because I ain't giving them. Okay, but I have to get some. I'm gonna just probably get 29, and it'll be okay. Someone's gonna go without cheese. I don't care. I got cheese. But then if I'm overcautious, and I'll make sure everybody gets their part of cheese. You want some cheese? I got some cheese for you, man. You want some cheese? I'm gonna get it. So go ahead. I'm gonna get 41 slices of cheese. It would be unusual for me to not have to use more than that, I guess. Does it make sense? Blah 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 blah. Math. Thanks, Chad. Okay. So let's keep cruising. What else do we got here? Graph action. Okay, how about this? Let's get done. This is one huge problem, basically, the blood donors problem, and then we're done with the section. Let's just be done, and then do like homework report day, whatever you wanted to do. Is that cool? Would that work for y'all? Yay! So one last problem. 17%. Pause. 17%. Wait. They already said it. People are eligible to donate blood. We select 4 people. There's your 4. What's the probabilities? All right. I would ask, say, like, hey, what do we do? And you're going to just say, GeoGebra. So, 4.17. And I'm going to just start writing these down because that's what they want. Dun, 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 dun. I don't know. That wasn't smooth math jazz anymore. That was pretty hip and happening, man. I don't know if y'all can handle that on the recording there. Are y'all okay copying numbers down? Isn't that just so thrilling? Best thing ever. I'm going to keep scrolling. It says, hey, which of these graphs looks like it would be correct? And what do you think? Looking around. Huh? See? Because I'm looking at the graph that they gave me. Wow. It's totally amazing. Because that's the graph over here. Now, is it skewed left or skewed right or symmetric? See? Yep, see how there's a tail over here? Yep, skewed right. Skewed on the right side. Yep, little tail action. We looked that up last time, didn't we? The skew? It was the shrew. Yes. Find the mean variance standard deviation. So the mean, again, I'm just going to multiply n times p. My n was a 4. My p was a 0.17. 0.17. Okay, 68. Actually, it's kind of weird. Let's just pause on this. That is donors. That's people. That's not 68% of donors. That's 0.68 donors. How many kids fit in the back seat of a car? 2.5, right? You got to cut one up. No, I'm just playing. That was a joke. So, I mean, that's kind of the thing here. How many donors show up? It's not even a whole person, okay? That's what it's trying to say. It's not a probability. Do you get me? Okay, because I know we're doing a lot of probabilities. I don't want to mix those up. Variance, I want to multiply it, and I want to show you how I do this in well, anywhere, honestly. I'm going to multiply it all together at once. I don't really need to know what Q is. So what I'm doing is I'm just going to insert Q like automatically in a way. What is the opposite of 17%? 80, 83? So you can type 83 in there, or you could just say like a formula kind of thing, right? But again, that's not the thing that we're looking for. I don't really care about variance. I care about the standard deviation. I'm going to square root that. And watch what I'm going to do. I'm going to square root ANS. ANS. And it pops up with your previous answer. And it makes it like a lot faster. I mean, could I just type the 5644, sure. I mean, that's not a problem, right? But if you wanted to type it quickly, ANS, it does it for you, which is really nice. Cool. Is that it after this? Okay, cool. All right, so we're going to use these numbers. You're all going to help me. What goes in this box? It says on average what? The 0.68. That's my average. That's my mean. Eligible adults every 4 give blood. A standard deviation of? Yep, 0.75. Excellent. Of most samples of the 4 would differ by at most. It's the same number. That differ part just means standard deviation again. So, yeah. Cool. What? No way, bro. Look at that. They're already done for you. Thank you. Now I felt kind of dumb. But confirmed that I was doing the right math. Well, I'm always learning something. Thank you. That was excellent. Yeah, so just look up here and it'll tell you the answers. Wow, that was super awesome. Cool, guys. Cool. Well, we're done with that section. And again, I don't want to go too fast. I know we're going to be reviewing, but let's do some makeup homework day, I guess, or whatever you want. If you want to leave, you can leave. I'm fine. Or if not, we will just do math. Are y'all good? Good to go? Okay, I'm going to stop recording. Here we go. Cub.